Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapkot. Dear students, in the previous class we discussed what is radiation heat transfer and what are the examples for radiation heat transfer, how to calculate the radiation heat transfer, then what are the properties of thermal radiation. In detail we have discussed in the previous class, dear students. Dear students, come today we are going to learn new topic, that is combined mode of heat transfer. Okay, so next topic is combined mode of heat transfer. What is combined mode of heat transfer? Dear students, in the previous class in separate we discussed what is conduction heat transfer, what is convection heat transfer, and what is radiation heat transfer. Separately we have discussed. But when it comes to combined modes of heat transfer, it is a type of heat transfer. It is not a type actually, it is a combination of two or more mode of heat transfer takes place in a system. That is known to be combined mode of heat transfer. Combined mode of heat transfer is nothing but simultaneously two or more mode of heat transfer is going to take place in a system. That type of heat transfer we can call combined modes of heat transfer. Combined modes of heat transfer is nothing but what, dear students? I will take in a system, just a minute. Okay, I will take a system. In that system, combined mode of heat transfer means both combined mode of heat transfer. That means what, heat is going to transfer from system to the surrounding or surrounding to the system in two or more mode of heat transfer. Convection and radiation it may takes, or convection, conduction, radiation it may takes. So if the heat transfer simultaneously takes place in two or more modes, then that type of heat transfer you can call it as a combined mode of heat transfer, dear students. How it is then? So to understand better, I will try to take in a live example and I will try to explain you. Dear students, what I will do, I will take in a example here now. This is what, a wall. Okay, then that wall is exposed to the sun actually. That wall is exposed to the sun. One thing, and also near to the wall there is a fire camp, dear students. Near to that wall there is a fire camp. Okay, fire camp. Okay, from that fire camp heat is moving in this direction. That means what, dear students, air is circulating here. The air will come and interact with the fire, then that air is going to absorb some amount of heat from the fire. Once it absorbs the heat, then that air becomes hot, then heat is going to transfer through a media, that is air. That heat transfer we can call it as a convection heat transfer. That means what, convection heat transfer is a mode of heat transfer in which heat is going to transfer from one point to another point due to molecular motion of the fluid. That is known to be convection heat transfer. Yes, when it comes to fire camp, convection heat transfer takes place one thing. So that we can call it as a one mode of heat transfer. Yes, convection mode of heat transfer is taking place using fire camp, one thing. And similarly you can see here now, sun is there. Simultaneously what happens, sun energy or sun radiation is going to transfer to the wall in the form of electromagnetic wave. That means what, the sun energy is going to transfer, that sun energy is nothing but what, heat energy is going to transfer to the wall in the form of electromagnetic wave, and there is no any media, but heat is going to transfer to the wall actually. That means what, radiation heat transfer is taking place here now. So that is second mode of heat transfer. That means what, dear students, with the help, because of this fire camp, convection heat transfer is going to take place to wall, one thing, and because of this solar radiation, the radiation heat transfer is going to take place into the wall actually. That means what, both radiation heat transfer and convection heat transfer is going to take place into the wall. If two or more modes of heat transfer takes place simultaneously in a system, that type of heat transfer you can call it as a combined mode of heat transfer, dear students. Okay, now what we can say here now, dear students, the heat is going to transfer from fire to wall through convection. So convection heat transfer, I can write it here, that is one. Then because of this solar radiation, the heat is going to transfer from sun to the wall. through in the form of electromagnetic wave, and there is no any media, that type of heat transfer we are going to call it as a radiation heat transfer, dear students. That is what second mode. So both convection and conduction mode of heat transfer, they are going to take place in this system. Then that heat is going to transfer to the wall, then heat is going to transfer from wall to the surrounding through conduction. That means what, if you are taking this same one application or one system, both conduction, convection is also there, radiation is also there. This is nothing but what, if two or more mode of heat transfer takes place in a system, that type of heat transfer we can call it as a combined mode of heat transfer, dear students. Okay, fine. Now heat is transferred from radiation, heat is transferred from convection. Then that heat is going to transfer through a wall. That wall, the heat transfer taking place in wall is nothing but what, conduction heat transfer, dear students. Once it conduction, this wall is gets heated, right? Then what happens now? Free air will come and it is going to interact with the wall. Then it will take away the heat to the room or surroundings. That you can see here now, dear students. This is a wall exposed to the sun. Then there is a fire camp. Then the heat is, some amount of heat is going to transfer to the wall through radiation. That is one thing. That is one thing. Then some amount of heat is going to transfer from fire. That is one mode of heat transfer. Then heat is going to transfer through the wall. That wall you can see here, dear students. That is conduction heat transfer. Then from this wall, because of air movement, that air will come and interact with the wall. That it will absorb the heat and it will move into the room again. That means what, heat is going to transfer from here to here, or it is going to warm up the room completely due to air movement or fluid movement or air molecules movement. That type of heat transfer can be called convection heat transfer. If some amount of heat from the wall is going to transfer into the room without any media, that is nothing but what, radiation heat transfer, dear students. That means what, both convection, radiation, conduction heat transfer is going to take place in this particular application. If two or more heat transfer, more modes of heat transfer takes place simultaneously in application or in a system, the type of heat transfer we are going to call it as a combined mode of heat transfer, dear students. Then this combined mode of heat transfer we can express in terms of thermal circuit. How it is, that we can see here, dear students. Okay, now so what I will do, dear students, you can see here now. So now assume that here you can take T infinity. T infinity is nothing but what, air movement. Sorry, here I will mark it, just a minute. The air is moving here, right? Air is moving. That air temperature I will mark it as a T infinity. Okay, and some amount of heat is going to transfer from sun to the wall, right? That amount of heat transfer I will mark it as a radiation heat transfer. The Q represent heat transfer, then radiation heat transfer. Then some amount of heat is going to transfer from fire to the wall. That heat transfer is convection heat transfer. That convection heat transfer I will mark here as a Q into QCM. Yes, QCM1. So convection heat transfer and radiation heat transfer, dear students. The temperature at this particular air movement I will mark here as a T infinity. That means what, heat is moving in this direction. That heat is moving in this direction. So that I will show here now. T infinity is the temperature. Then radiation heat transfer I will show it here. When there is a radiation heat transfer, right, there is some resistance also. That resistance we can show it in this fashion. Then convection heat transfer. That convection heat transfer I will mark it here as a QCM1. Both radiation and convection heat transfer, they are going to takes place in the plain wall or a wall. That we can see here now. This is a wall, dear students. Okay. Now through that wall conduction is going to takes place. The temperature at this point I will mark it as a T1. The temperature of the wall at this point I will mark it as a T2. Hence this is point 1 and this is point 2. The temperature at point 1 I will mark it as a T1. Temperature at point 2 of the wall I will mark it as a T2. Then thickness of the wall I will mark here as a L. That you can see here, dear students. Okay, fine. Next, what I told, whatever the heat is transferred, right, through conduction, it is happened from this wall. Again heat is going to transfer into the room through two modes. One is convection mode, another one is radiation mode, dear students. With the help of some air movements, the heat is transferred or room is warmed. That is convection heat transfer. Without any media, the heat is going to transfer from wall to the wall into the room through electromagnetic, in the form of electromagnetic wave, and there is no any media, that is nothing but what? Radiation heat transfer. That means what? That I can show here now. So heat is going to transfer into the room in the form of radiation heat transfer. That the radiation heat transfer into the room, I will mark it here QR2, dear students. So that means, 1 minute. Okay, fine. So heat transfer into the room through radiation, I will mark here as a QR2. The heat transfer into the room because of molecular motion or air movement, that I will call it as a convection heat transfer. That convection heat transfer I can mark here as a QCM, convection heat transfer. This is the same thing I have marked here, dear students. That means what? Radiation heat transfer in room is QR2, convection heat transfer in room is QCM. Then whatever the temperature is there in the room, right, that is T infinity, I will mark here now. T infinity 2, T infinity 1 is nothing but what? The outside of the wall. Both combined, radiation and heat transfer. What is the temperature of the things at this side, right? That I will mark here T1. When it is come to room, right, then I will mark it as a T infinity 2. So that I have shown it here, dear students. That means what? Heat is moving in this direction. Fine. So this is what? Schematic diagram of the given of the combined modes of heat transfer. When it comes to this wall, right, it's a brick wall or metal wall, whatever you can take, it is going to have a thermal conductivity. What is thermal conductivity? Thermal conductivity, it's a property of material, ability to conduct the heat. That is nothing but thermal conductivity. What is thermal conductivity? How to determine thermal conductivity in detail we are going to discuss in upcoming class, dear students. Okay, fine. Now this schematic diagram, whatever the heat transfer is taking place in this particular application, right, that I can express in terms of thermal circuit. How it is, that you can see here, dear students. Initially the temperature is T infinity 1. So T infinity 1, then heat is going to transfer into two modes. One is radiation heat transfer, another one is convection heat transfer. So that radiation heat transfer I will show here as a 1 divided by R1A. Then convection heat transfer I can mark here as 1 H1 by A. That is happening in parallel. Okay, one thing. Then later after this, heat is going to transfer into the wall. That is nothing but conduction heat transfer. That I can show it here now in single, right? So there also some resistance. That resistance we can mark it here as a R. Then that resistance is nothing but what? L divided by Ka. Here convection, whatever the radiation happens, right, there also some resistance. That resistance I can mark here as a 1 divided by HR1A. Some resistance, there is some resistance in the flow of heat in convection heat transfer. That is nothing but what? 1 divided by H1 into ADS, students. Fine. Then conduction. Okay, after that conduction, what I told, heat is going to transfer into the room through again radiation and conduction. So if it is a radiation, there is also some resistance in the flow of heat. That we can call it as that we can mark here as a 1 divided by HR2A. Then some resistance in the convection heat transfer I can mark here as a 1 divided by H2A. Then final temperature I will mark here as a T infinity. This is nothing but what? Thermal circuit for combined mode of heat transfer, dear students. Okay, then how to determine? If I want to know the total amount of heat transferred in this in this combined mode of heat transfer, then how to calculate? Yes, we can calculate the combined mode of heat transfer. How it is, that we can see, dear student. That is Q divided by A. That means what? I am going to calculate rate of heat transfer per unit area. That is Q divided by A is equal to T infinity 1, high temperature minus low temperature, that is T infinity minus 2, T infinity minus T infinity 2, then divided by 1 divided by convective heat transfer coefficient radiation heat transfer coefficient plus convection heat transfer coefficient, because combined it is going to happen here now. That resistance I have already shown it here now. 1 divided by HR1 plus H1, because A is nothing but what? Common, I have taken it here now. So then 1 divided by H1 plus 1 divided by HR1 plus it is what? Okay, we have to the resistance L divided by K. because A I have taken it out. A plus 1 divided by HR2 plus 1 divided by plus H2. This is nothing but what? Calculating the combined modes of heat transfer for unit area. Here, where HR1 and HR2 are the radiation coefficient, HR1 and HR2 are the radiation heat transfer coefficient, whereas H1 and H2 are the convective heat transfer coefficient, whereas K represents thermal conductivity and L represents thickness or length of the wall, what we have considered. Then T infinity is nothing but what? Temperature at high temperature region. T infinity 2 is the temperature at low temperature region. This is what? Combined modes of heat transfer, dear students. If you understood this, please do like and subscribe and comment me. Thank you.